I'm Luke, and I work at a Clojure shop in Bristol called English Language iTutoring, or ELIT. I've been building ClojureScript applications for about 4 years, 4.5. Up until about 3 years ago, it was UI tooling, really. And but the last 3 years at ELIT has been production, sort of single-page applications and services too, so full stack. And on building our latest single-page application, I noticed that it sort of struck me that the way that we were building it has completely changed and evolved, and it'd be good to sort of share exactly how that's changed in this talk. And aware that some of you don't know about Clojure, so I'll give you a bit of an introduction about that, and ClojureScript too. For me, ClojureScript started, I first heard about Clojure and ClojureScript about 2011. This is a screenshot for an IDE called Lighttable, and that was inspired by a talk that Brett Victor gave called Inventing on Principle. And he was trying to emphasize that creators, they need an immediate connection with what they're creating. And here we're seeing a game, and we have the Clojure functions, which represent parts of the game. And when I started playing around with ClojureScript, it's not really the experience that I got, the sort of things that were being demonstrated at the time. The DOM has been conveniently left out. I think that was a particular pain point for quite some time. So yeah, it's 2018, and it's come a long way since. So to start at the beginning, what is Clojure? It is a functional programming language, and by that I mean emphasis on writing pure functions. If I call the same function a million times, I expect the same output. I don't have any hidden inputs or hidden outputs in my functions, so everything that it does, it depends on the explicit list of arguments I give it. Likewise, I try to avoid side effects and move the side effects that you do need to make in your application or your program to the periphery of the system. It targets both the JVM, that's what we refer to usually as Clojure, and ClojureScript targets the browser and Node.js as well. The back-end language of choice still is Clojure, targeting the JVM, but there are sort of ClojureScript apps that compile to Node.js out there. Yes, it's dynamically typed. There are optional options for typing in ClojureScript, but they're not sort of widely adopted in the community. It's still ongoing work. There's a really good validation library called Spec, which entered the language a couple of years ago, and that's really useful. But just know that you can get some sort of family of runtime exceptions that you wouldn't get in a statically typed language. And yes, it's I suppose the most obvious thing that you see when you first present it with Clojure is that it looks different. It's a Lisp, and so Lisp was invented, or they say discovered, by this guy, John McCarthy, in the 50s. They say discovered because really it was so simple that it almost couldn't have been invented. It was the core principles can be described in no time at all, really. This here is how we would represent a list in Lisp. It's an element, 3 elements in a list, 1, 2, and 3 numbers. And Lisp extends that and says, well, why can't we express a function as a list where the first argument is the function, and then everything to the right of it are the arguments to that function, and which is known as prefix notation. So yeah, as the rules of evaluation are dead simple. You evaluate the arguments that's the second position from left to right, and then you apply the arguments that you've just evaluated to the function. So this, what we call an S expression, reads, you would evaluate AA first, and then multiplies the asterisk, and then BB asterisk, and then those two return values would be filled into plus and then a square root to give you the result. parentheses are a complaint to non-Lispers, but they just sort of disappear eventually. You have to trust me on that one. And this is a really nice, profound quote, which is from the textbook SICP. All of the formal properties can be covered in an hour, like the rules of chess. After a short time, we forget about the syntactic details of the language because there are none, and get on with the real issues, figuring out what we want to compute, how we will decompose problems into manageable parts, and how we will work on the parts. And I can't. That's so true. Really, working with Lisp. At the core of Clojure is the idea of immutability, which I think is also sort of quite heavily prevalent in the JavaScript community as well. We prefer to program with immutable values rather than objects. And the main motivation for that originally was for concurrency reasons. If you've got lots of processes which are mutating shared state and you stop your program at any point, then it's very, very difficult to see exactly what's going on and understand problems if you are having problems and you often are in multi-threaded environments. Obviously, that's not a problem. In JavaScript, it's single-threaded, but you'll just have to give it a try and realise that it's much easier to reason about. If I define the foo to be a string bar, I can be sure that for the entire duration of my program, it's not going to change, and that's a really nice property to have. Clojure is built around these, I say mainly for immutable data structures that you'll find in Clojure code bases. On the left, we've got the functions which evaluate to the literal syntax, how you would usually express these data structures in Clojure code. And they have the sort of semantics that you would expect from these sorts of implementations of data structures. A set has distinct elements, for example. The exception, of course, is that they are immutable. They cannot be changed. If I apply a function to one of these data structures, it's going to give me a new. So this is a vector, and I'm using a function called Conshare, which means it's short for conjoin, adding 6 onto a vector 1 to 5. That's going to give me an entire new vector, and we don't need to resort to copying for this because we can do some fancy stuff underneath the hood. Because it's immutable, we know that we can share state between the old version and the new version. So here, 6 is the only thing that we're actually adding into memory, and we're referring to the 1 to 5 elements from the previous data structure. It's a really interesting implementation, and immutable.js is basically that ported to JavaScript. The trade-off is if we don't get constant time lookups because we have to traverse a tree, but the tree is really shallow, it might as well be constant time. There is an abundance of functions in the Clojure core. So Conj, for example, also works on lists, it will work on maps, it will work on everything, and that's true of a lot of the functions in Clojure. Better to have 100 functions that works on one data structure than 10 functions on 10 data structures. So if you do need to mutate state or share state across processes, you do have reference types in Clojure. So Clojure on the JVM has atoms, agents, and refs, although the latter two are rarely ever used. ClojureScript, just atoms are implemented, and the underlying implementation is very simple. This is what it looks like in JavaScript. It's just a way of of implementing assignment in Clojure, but we have to explicitly do it here, but using this atom. This is the kind of preferred way of doing it, where you apply a function to the current state of A to get a new state. If you want to learn more about Clojure, I can't recommend Rich Hickey's talks. They I think pretty much changed my career when I watched them when I was a C++ developer. And if you're still not convinced about functional programming, then there's a really good paper called Out of the Tar Pit that's also excellent. So ClojureScript. It transpiles JavaScript, so this is a Clojure function above here, and this is what it spits out. You can see this is quite a simple transformation here. The ClojureScript compiler spits out quite naive JavaScript, and in order for it to be fast, efficient, for size and speed, we run it through the Google Clojure compiler, and that does a good job of minifying the names of the functions. Not only that, it also analyzes the code, and it's much faster than, let's say, Uglifier, which is just a minifier. It actually does analysis, and it will strip away stuff that you don't need. Unfortunately, it does come at a cost. Google Clojure compiler its worldview is only what you feed into it for compilation. So if you're referencing a library in JavaScript that Google Clojure compiler isn't aware of, and then you munge all the names, then any references in your code to a function that's external from your code will be munged too. So do stuff here might become like MB or whatever, and then your code will break. And so for a long time, what we had to do was create these externs files, which has, please don't munge these names in it. And that was a real pain in the arse. CLJS was an effort to take libraries, really nice libraries in the JavaScript community. I mean, it's the largest ecosystem on the planet, really, and make them suitable, package them up into jars for putting into ClojureScript projects with all the externs in there. But every time you want to use a JavaScript library, it was a real pain to actually create one of these packages, submit a PR for it, get it merged in, and then using it in your own projects. And unfortunately, as of last year, this is a problem of the past. We can just use npm libraries and include those. They get passed actually into the ClojureScript compiler, the Google Clojure compiler. So because the Google Clojure compiler is aware of all its dependencies, it can optimize those too. And we've also got first-class sort of ES6 imports in Clojure namespaces, so we can actually just require a module, an ES6 module, and then reference it in the code, and it's dead simple. We don't even have to deal with externs files anymore. The only other thing we have to do is to add some type hints if we're dealing with JavaScript objects in ClojureScript. So if we want a really nice way of representing HTML in Clojure code is using data structures. I didn't really mention actually back there, but Lisp code is data. Emphasize that point. Function is a list, and here we're representing HTML as nested vectors and maps. So maps to describe attributes, and other bits just to represent the sort of nested structure of a DOM. You can see, I hope, how this translates over here. And this is not the only way of representing HTML in Clojure code, but it's a really nice, popular way of doing it. So I guess the next question is, how do we actually work with the DOM? How do we manipulate it? There are a number of ways there are a number of options you have in ClojureScript, but I'd say the one that we're using is quite sort of a well-trodden path. At the bottom is React. So ClojureScript has really good support for DOM rendering frameworks so long as they are React. It's a really nice fit. So that handles all of the reconciliation between our virtual representation of the DOM and the DOM itself. On top of that, we have a library called Reagent, which allows you to represent hiccup functions that return hiccup, and so React components as functions, and then Reframe, which is essentially Redux. It's our layer on top to dealing with messages and subscribing to change. Yeah, it's a really good fit, Clojure and React. I say why. I mean, the underlying algorithm is very, very functional. We have a function that takes props, our state, to give a representation of the virtual DOM. We do it again with a different, with the status changed, and then we just diff the two together. The nice thing about working with React in Clojure is that because the props, the state, is immutable, it's much, much faster to compare when things have changed, when the props have changed. So yeah, there's a good speed up there. Reagent, as I said, represents a React component as a function. This is hiccup. This is a function that returns hiccup. Reagent extends the ClojureScript atom, which is, as I said, is just a bit like assignments, to make it reactive. So this counting component at the bottom here is being dereferenced, and then every time that this click count atom is dereferenced, is changed, this reagent, the atom is context aware and will re-invoke this counting component render function whenever its value changes, which is a really, really nice way of working with React without having to sort of get involved in some of the details of the API. A lot of the time we're writing render functions that don't use life cycles. In fact, I'd say most of them don't. But there's no loss of expressiveness at all. We can still use all of the sort of React 16 features, so that's not a concern if you're thinking about using Reagent in a complicated React project. And Reframe, this is very, very, very much similar to Redux. The idea is we put all of our state in one place, and we transform that state using a series of event handlers that we define, we apply a function taking the state as argument and produce new states, and our entire sort of the journey from the start of our application to at any point can be deterministically built up by just applying these or reducing these functions. In order to render to render the state of the application, we just do the same. We apply a function to our state to return a value which is suitable for rendering. That gets passed to our reagent render functions, which props in React parlance. So an event handler, this is like a JS on-click event, when that event handler triggers, we'll dispatch an event handler registered to update click count, with the value of the event, and we define a event handler like this. DB here, we take the DB as argument plus any other arguments, so click count here, and then this function returns a map. One of the keys in the map is the change DB, or a new value of the DB. This bit at the bottom here does something extra. We are making an XHR request to this API resource. This function does not make the request. It just contains instructions to make the request, and it's handled by a downstream effect handler. And this is the way that Reframe encourages you to write to deal with side effects, is that you just say, look, this is how I want you to handle an XHR request, and these are instructions to do it. And the benefit in doing that is that your code is so much easier to test. All of our tests ELIT run on the JVM. Most of our UI tests, and we essentially just like navigate. We have helpers to navigate to a route that triggers a bunch of reframe event handler functions, and then we subscribe to the result, and we can stub out effect handlers however we like, or mock them out and inject behavior however we want to. So it's really, really powerful. And the subscriptions, whereas before the example I showed you with reagents, we have a reagent atom, and then we dereference the atom in the render function like that. To do this with like directly with the app, the DB, which can get quite big and is not really in the format in which we want to render it, we could be a bit cumbersome and it's not going to scale. So with Reframe Subscriptions, we just replace the reagent atom with a subscription that we've registered that's registered to this keyword click counts, and when we deref it, we'll get the value that's returned by this function, and that is what the click count subscription returns. But this can be as simple as complex as you like. Really, and the really nice thing about Reframe Subscriptions is that deduplicated. So if you've got lots of elements on the page which depend on the same subscriptions, then only one that code will only run once the app DB changes. So it's quite efficient, nice reactive way of constructing the code. So I'm going to do a little demo now of one of the projects that we're working on at the moment, a single page application, and really just to show you some of the tools that we're using. If I can get, yeah, cool. So one of the first is a Clojure, I guess you could call almost like a pattern library called dev cards, and the idea is that we build our application out of components, like reusable components, and we can develop this component in isolation. We don't have to go through some like rigorous sort of annoying amounts of steps to get this component to appear on the screen, and you know I can edit it and I can see the changes appear in real time, and that's a really, really nice way of working. And we've got quite a few in our latest project. We've got quite a few different components that we have here. It's a really useful reference to see how things work. So this is a work in progress. Speak and improve. This is Sandy, the avatar. And if I get up Emacs, so, oh, hold on. Don't kill Emacs, please. Cool. So a really, really nice interactive way of writing ClojureScript is by connecting a browser REPL. And so I can send commands to the browser just like I would in the inspector in the console in Clojure. So yeah, that's it's really useful. Also, if I want to evaluate, where am I? If I want to evaluate, it's really hard to program behind your back. Evaluate code. It takes a second or two, but I don't really notice the delay, you know, anymore. And what else? Yeah, there's a tool called Refrisk, which helps with debugging reframe applications, which is really useful. If I can kind of drag this up. Here we go. You can see this is the state of the app at the moment. As I perform event handlers, once I trigger event handlers, they'll appear. down the right here. The last one I did was trigger an animation, and we can see all the subscriptions as well that are active on the page, which is really, really useful when debugging. There is a tool called 10x, which is a sort of revamped version of Refrisk. Looks like this, but we're not quite using it yet because it's a little bit buggy. It's very, very impressive at what it does. It allows, you can see some code here, and you can actually see proper tracing in these windows. But yeah, it's not quite there yet. I'm really excited though to once they get on top of the issues to start using it. And I suppose just to finish off, just to say like the thing which has completely changed the experience lately is moving from the CLJS build tools to Shadow CLJS. It is a project by a guy called Thomas Heller, and he's put a lot of effort into it. And the aggressive caching, the NPM dependency support, and some of the other sort of advanced features that you need when building a single-page application for the masses, like code splitting and fingerprinting assets. It's all kind of there, and it's thanks to him. So yeah, I'd say like it's a serious contender now. When I started writing single-page applications a couple of years ago, seriously, it was quite painful. The areas of it, some of it was a joy. The language is a joy, but now sort of everything just seems to fit together quite nicely. So I'd encourage you to go out and give it a go. All right, thanks very much. Cheers.